Let me walk through 16 and 20.
Thank you.
You're looking for the order pairs that create this. So, guys, ladies and gentlemen, you can close the books now because I'm going to do these. You don't need them. Thank you very much. You're good. Sweet. So, remember, as we're walking through these constraints problems, this linear programming, if you will, what we're trying to do is we're trying to find a shaded region boundary that will pluck out the ordered pairs, if you will, to substitute in to see if it's a maximum or a minimum of our objective function. These objective functions, they give to you what C equals something. Today, we're going to start building them out of word problems, and I actually have the handout for you guys for the word problems. We'll walk through a couple examples of that as well. And from what I've heard so far from a few people from second hour and some that were back here in Flex today, they were saying that they find this a little bit easier because they know where this is going to now. Why are we finding this constraint? Why are we coming up with these objectives? It's easier to see it once you start putting it in terms of a word problem. So on Friday we talked about these things as constraints, and we developed a quick way of doing things by doing quick graphs via their intercepts. We also learned that in this case here we have x is greater than or equal to 0, y is greater than or equal to 0. It gives us a quadrant 1 problem. So we're just drawing first quadrant. And you're going to see a lot of first quadrant styles here. We know that it's x is greater than 0 is going this way, y is greater than or equal to 0 is going that way. Now we find our intercepts. The third graph has x plus y is 7, which means I have a y-intercept of 7 and an x-intercept of 7. That's easy. And we label it right away. Connect the dots, la 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 la. Did it go through the origin?
No.
No. So we use 0. What's 0 plus 0?
0.
Is 0 bigger than 7?
No.
No, so it's false at the origin, which means it's true going out. So we have that. So far, so good. Do the same thing for the next one. Y-intercept of?
10.
X-intercept of?
4.
Good, buddy. Yes, it was supposed to be a joke. Because he said 10, 4, and I said, good, buddy. What's 0 plus 0? 0. Is it bigger than 20?
No.
Again, it's false, so it's true moving out. Now, you have to be careful where the overlap occurs. The overlap occurs doing that. Everybody see that?
Yeah.
Now, is there a lid on this problem?
No, so there's no
There's no maximum. Exactly. So there's no lid on it, so we know right away just by looking at this, there's going to be no maximum.
Wait, what do you mean no?
We've had other problems where it bound itself out and we had a shaded region like that where it was enclosed, completely enclosed. This is not fully enclosed. Like the first example I was walking you guys through Flex, remember how I created a triangle? We had 3 ordered pairs and it was all incorporated within those. This one has no lid, it has no hypotenuse, it has nothing to stop the max. It's shaded fully out this way. Oops. So we know it has no max. Whatever. But we have to find out the one other intersection point where these two lines ran into each other. So when we do that, we're treating it like a system of equations again. We don't worry about this being a greater than or equal to or less than or equal to any of that. We treat it just like it was a regular old boring equal sign. And the quickest way to solve this system is to say that x equals 7 minus y. And I direct substitute into here. So I had 5 times the quantity, 7 minus y, plus 2y is 20. 35 minus 5y plus 2y is 20. 15 is 3y. 5 is y. If 5 is y, what's x? 2. So this ordered pair is 2, 5. That's what you're doing. So now you have those 3 points to test to find out, well, we know there's no maximum because there's no lid, but we test those 3 to see which one becomes the minimum value using the objective function, which was negative 2x plus y. We have 0, 10, 2, 5, and 7, 0. I have to admit, I think the question says state the maximum and minimum value. I believe that's what it was. Gee, which one is the minimum? I don't know. The negative 14. And this becomes our minimum value. That's what we're looking to do. Okay? Yeah.
Is it always going to be like which one's always?
Not necessarily. Okay? It really depends on the function.
Sorry.
Okay? It depends on because that's what you're looking at. Yeah. Can I do 20 first? Because I've had a lot of questions on 20. Let me look at 20 real quick. Guys. I've had a lot of questions on number 20 because people have forgotten a very quick step in graphing lines. So if I go back to 20 here, do we all agree that it goes back to first quadrant right away? Yeah. It goes right back to first quadrant. We don't have to worry about any of that. So I have first quadrant problem. I'm going to graph that third inequality last, and I'll explain to you why in a second. 2x plus y is 4. It gives me intercepts of x and y at 2 and 4. Is 0 plus 0 bigger than 4? Moving out. X and y intercepts here at what would it be, 6.5 and 13. I hate decimals, but sometimes they're just quicker to write, especially if I'm just kind of fudging it as far as intercepts are concerned for a graph. Instead of saying 13 over 2 comma 0, I just say 6.5. I can scale it a little bit quicker. Are we okay with that? And then the other one was what, 13? Is 0 plus 0 smaller than 13? Yeah, so this one's moving inward. So right now we have this ribbon, if you will, that's shaded. Graph the middle one, the negative x plus y. If I do cover and solve, it gives me x and y intercepts both at 0, doesn't it? But where do you draw your line? Well, get y by itself. What do you get? Y equals x, isn't it? Slope of 1, y-intercept of 0. That's all that is. Isn't that all that is?
Yes.
Yes, sir. Pick a point not on the line The easiest point that's never on the line, or a lot of times is not on the line, is the origin, 0, 0. That's all I'm doing. You can pick any point you want. You can pick 7 and 4 if you'd like. If it's not on the line, go for it. 21 and 3. 77 and negative 44. But yeah, the origin's always the easiest. Now in this case, I can't use the origin because it won't work, but where are numbers going to be bigger than, where are numbers larger for y than they are x? Above that line or below that line? Above, right? So it's got to be moving upward. Which now gives me an ordered pair here and an ordered pair here that we have to find, because we have our shaded region bound by this quadrilateral, like that. So we have to figure out where this line intersects this line and where this one intersects this one. And again, we're going to treat it like direct substitution, since y equals x. It's just a matter of plug each other. So if I say y equals x, I get 2x plus x is 4. That means my ordered pair is 4/3 and 4/3. And I do the exact same thing with the other line. Y equals x. 2x plus x is 13, which means x is 13/3. And I'm back to having my I have 4 ordered pairs. Yes, sir?
When you get 2x plus x equals 4.
What we're doing here is this line is y equals x. That line intersects 2x plus y is equal to 4, and it also equals 2x, right? It intercepts 2x plus y is 13. To find this ordered pair where they're run into each other, I'm solving a system of equations with y equaling x. So I just directly substitute in x for y. That's it. That's why we did the solve the systems last week, because we use it here. Okay. So we solve that quick system, and now you just check your ordered pairs for 10x plus 3y at 0, 13, 13/3, 13/3, 4/3, 4/3, and 0, 4. And all you have to do is just throw it in the calculator. That's it. And whatever one of those is the biggest number is your maximum, and whatever one's the smallest number is your dun, dun, dun. And you guys thought you were going to lose. Not so scary?
What were you talking about putting in the calculator?
Oh, 10 times 0 plus 13 times 3. 10 times 13/3 plus 3 times 13/3. Just substituting that to figure those out. That's all. Not so bad? No, you're not. You're in school. You're in E218.
You don't even know where you are.
Do I ever really know where I am? I could have stolen that from somebody else. If it gets plugged in. Not really in my contract. I honestly don't know where you guys get.
So basically tonight we're doing the same thing, we're just pulling the numbers out of.
Yeah.
Okay.
Okay. So you were asking about 14. 14 creates the cylinder. And we know one thing here is that you have a boundary for your x values, -5 and 0. So if I draw this out in a regular grid. X is greater than -5. That's here. And it's moving up. X is less than or equal to 0 is here. And it's moving down. So you've got that ribbon. Now we're going to put ends on it. At -2 and +2. Y equals -2. So y is greater than -2, greater than equal to, excuse me. And y is less than or equal to 2.
Yeah, this is, can you make it Y is on?
X doesn't go on.
Yeah, I did it. Yeah, I did it.
Wow, I did, didn't I?
Yeah, I did I really do this all wrong?
Oh,
Oh no! You tried.
I don't. Sorry about that.
Wait, so you just got totally wrong?
Yeah, because I.
Can you mark where like this? And then can you make the next line a different color?
You guys are demanding.
There's so many lines in it. Yeah, and then just slide it like by the
All right.
And it's red.
X is greater than or equal to -5 is here. And it's going this way.
Oh, yeah.
X is less than or equal to 0 is here. I apologize, I don't know what I was thinking. And it's going this way. So now we have that vertical ribbon to start with. Then I put the top and bottom out with the Y's. Is it greater than? So we have these 4 ordered pairs here. Okay. And you know the x coordinate for the vertical line on the left is 0. So both of these points here have the same ordered pair of 0, 0, comma. Well, what's the y coordinate here? And this is at and that gives you your 4 points to check. We actually use vertical lines a lot today. So hopefully I don't screw it up again. Okay? Yes, sir. Those are the 4 points you would check then. Which one gives you the biggest number? Which one gives you the smallest number?
I've never done that since where you run out of
So what I did here today, so you don't have to print everything out, I hole punched, you're welcome, some of the word problems that we're going to start to work with. We're going to add our homework to this tonight. We'll just add to these. So what I want to do as these things are going around here is I want to start showing you guys how this starts to, I don't want to say apply, but how we're going to be able to utilize this short, quick graphing into our own objective functions. So I'm going to start looking at I don't count. You guys all get it? Seriously, what's the point? I just throw them at you. I'll get the options eventually. I counted the right amount. I handed the right amount.
Yeah, that's how I got all these.
Yours are okay. It's kind of 4 is pretty easy. Yeah, but there's no classes in college for counting. There's accounting classes, but no counting classes. Yeah, you can assume a lot, but you make an angle side out of it.
Wow.
Rolling!
Wow.
goes on your face.
All right, so let's go. Slowly. Come on. When did it start? Ladies and gentlemen, let's take a look. Guys, this takes a little bit of time to start to understand the lingo here. So if we read for the first one, guys, I don't want to talk over everybody. We waited. Fly High Airlines sell business class and tourist class seats for its charter flights. To charter a plane, at least 5 business class must be sold, and at least 9 tourist ones must be sold. The plane does not hold more than 30 passengers. They make a $40 profit for each business class and a $45 profit for each tourist class. In order for them to maximize profits, how many tourist seats should they sell? What's the objective?
Easy.
Make money. This problem, the objective is to make money, make the most profit. How are you making profit?
By selling tickets.
Okay, so in this problem, you have business class seats
And tourist class.
and tourist class seats. You want to figure out, well, you want to maximize your profit. So for each business class, how much profit do you make? 40. 40 times these, plus 45 of those, is your profit. You want to maximize profit. That's your objective function. Oh, now you're going to come up with your own constraints to the problem. First thing I'm going to ask you, can you sell negative seats?
No.
Which means what quadrant is this? Quadrant 1. 1. I know that I'm going to have greater than or equal to business seats of 0, greater than or equal to tourist seats of greater than 0.
It's 5.
But it says it need to have at least 5 business. So that means this supersedes it by being greater than or equal to 5. And the tourists have to be greater than or equal to 9. How many seats does the plane hold?
30.
So you add those two together, what does it have to be less than or equal to? Because the plane doesn't hold more than 30 people. So the combination of business and tourist seats has to be, or tickets sold has to be less than or equal to 30. So from there, you've got your constraints. But it's not written in terms of x's and y's, is it?
No.
So you just have to determine where you want to label your axes. I will suggest when you do these problems to go alphabetical and do this. But as soon as I label my axis, I'm going to put off to the side an ordered pair. Instead of being x, y, I know it's b and t. That way when I go back later on, I know what the numbers correlate to. Does that make sense? And now I just go through and do all my quick graphs. Sometimes this is a little oversimplifying, but we want to look at, we know you have intercepts of 30 and 0, and 0 and 30 here. And it's moving inward. This is the very last one. Sometimes it's quicker to graph that one first. I know it has to be greater than or equal to 5 for here. Whoop. Airplane took off without us. Yeah, that was good. I am. Sometimes I think I am kind of funny.
Sometimes we don't.
So I know that that vertical line is at 5, and it has to go which direction for shading? To the left or to the right? To the right, good. I also know that when it intersects the line here, it has an x coordinate of 5, which means how many tourist seats would it have been? 25. And then I do the same thing with the 9. it's moving this way. What's that ordered pair? 5 and 9. This one is something and 9. 9 plus what is 30? So you get your boundary.
Oh, and so like it tells you, okay, B and T is how many seats you should sell, and the max is 5 and 25.
I don't know if it is or not, because you have your 3 values to substitute in for
Well,
your
if you do
objective.
the math though. then
If you do the math, if you do the math, you have 3 of them to check. You have 5, 25, 5, 9, 21, and 9. It was 40 B plus 45 T. So 40 times 5, 200. 200 plus, well, 45 times 25 is,
No, I don't know.
I don't know, math it for me, would you? Thank you. Yes, ma'am.
Yeah.
This is the T value for 9. What plus 9 is 30? That's all it is. This is a system of equations.
Oh, and then you subtracted 5, 6, or 5, yeah, 5 is 30.
Yep. Because just like we did earlier when we had the vertical getting ordered pairs with the horizontal and vertical
So
lines.
does that always work then, or is it just?
If it's horizontal and vertical, yes. If it's not, if they wind up being crisscross, the lines that aren't horizontal and vertical, you're solving the system, and that's what we've been working. That's why we did that. Yes.
Wait, then how did you get T is greater than or equal to 9? B is greater than.
It said in the problem. It said at least so many seats of this, at least so many seats of that. You were probably talking.
Am I right? You didn't realize it was a pair. Am I right? No? Oh, wait.
Okay.
No. 5 and 25 is the greatest. We sell more of what was messaging and ones that we least compared to.
What are you getting?
5 and 9. I got, because 5 and 9 we.
You got it?
I did this and I found the answer before we even did it correct.
So at 5 and 25, you get 1325. Is it 1325?
Yeah.
5 and 9 is 605. And then what's the last one? 1245? Okay.
I'm not just talking.
But remember, it depends on your objective function for which one it winds up being. Sometimes the 21 and 9 works better for profit-wise. You always double check them. Okay. Let's look at the next one. Apparently you're part of the Plexus Dance Theater Company that's going to the University of Georgia. Yeah, I think our final one here, the tourist seats, I think your answer winds up being 25 of them. 5 business class and 25 tourists.
Why does the tourist seat cost live? Because I thought tourist was like economy and business is like.
Maybe they got a meal.
Okay.
Maybe they got a commemorative meal.
Are the answer made for by their. Yeah. You send me them on a visit. Like, my dad got pajamas and everything.
It was 25 tourists to the overall. So, if we go to the next one. The Dance Theater Company appears at the University of Georgia. According to school policy, no more than 2,000 general admission tickets can be sold, and no more than 4,000 student tickets can be sold. It costs 50 cents a ticket to advertise to students and $1 to advertise to the general public. The company has an advertising budget of $3,000. Find the maximum profit the company can make if they charge $4 a student and $7 a general admission ticket. Okay. And then obviously it goes into the next part where it's how many tickets should they sell. So we have some constraints. First thing we notice is that can we have negative sales of tickets? No.
Wow.
So we know that we have, our objective is to make profit. We have student tickets and general admission. So let's call,
G and
yeah, $4 for the student and $7 for general admission. And I will try my best to overcurve my S's so they're look like 5s. We can't sell negatives. We know that they're both greater than or equal to 0. And it also gave us an information that there's a cap on them. It said at most, what does it say? No more than 2,000 general admission. So what's your upper boundary for G?
2,000.
2,000. So it has to be greater than 0, and it has to be, G is then also less than or equal to 2,000. What's the cap on students?
4,000.
4,000. So with that information, we already know that we've got a rectangle. If you just start thinking about it. And then what was the other constraint that they had? Their budget, their advertising. How much did it cost to advertise to students?
50 cents.
50 cents to a student and $1 to the general admission. And they had, what was the operating budget? $3 grand?
$3 grand.
So this actually has 5 total constraints to it. Yeah, it's hard, but it's not crazy.
Impossible. It's not hard. It's just
Okay. So let's go through. We know it's first quadrant. This problem is kind of weird because we started with student and then we went to general admission. So I might say my student is my X, my general admission is my Y, and not go the other way. But just be careful on however you label it. It still works, but since I wrote it first, I'm going to kind of do this. Just sometimes it happens that it's easier to keep it straight. Whatever you write down first, if it's not alphabetical, make sure you label it, that way you don't mix it up, because a lot of times it'll flip-flop. Bless you. So I have a vertical line at 4,000. I have a horizontal line at the 2,000 then, right? Oh, I'm sorry, I have that backwards. Nope. Did I label it stupidly? Yeah. So this is 4,000. And then I have to worry about my other 2 intercepts. I have a general admission intercept at 3,000. And then what's 3,000 divided by 0.5? 6,000.
I have a question. So since it's like a less than sentence, wouldn't that just automatically tell you that it's shaded under? This less than is less, so like it'd be under the line instead of over?
Not you always want to be careful because you have if you have signs in between.
Yeah.
I would just be careful. Okay. And we knew we were moving inward. If this is 4,000, .5 times 4,000 is how much? 2,000. 2,000 plus what is 3,000? 1,000. See how I'm just substituting in, because it's vertical at that point. I can substitute and find my other value. That's all we need to do. We know, if you think of this in terms of x's and y's, all I'm doing is taking an x value of 4,000 and I'm substituting in here. What's half of 4,000? 2,000 plus what is 3,000? That's all I did. And I do the exact same thing going here, where it was 0.5 of something plus 2,000. Move the 2,000 over. What's 3,000 subtract 2,000?
1,000.
So half of what is 1,000?
2,000.
2,000. So this ordered pair wound up at 2,000. Mhm. So you have your ordered pairs then to check out at. You have nothing and 2,000, 2,000 and 2,000, 4,000, 1,000, and 4,000, and nothing. And our objective was what? 4S, this is S and G.
Would 0, 0 be a 4?
Thank you. 0, 0 would be, but do I need to worry about that one?
So it's
I-
automatically your minimum.
It's, in this case, yes, this will be automatically be my minimum. I don't have to worry about that because we're trying to maximize the profit. And it's just a matter of going through the through all these. So we have 4 times 0 plus 7 times 2 grand. 4 times 4 grand, or excuse me, 4 times 2 grand plus 7 times 2 grand.
Yeah, these are just time consuming. They're not like difficult. They're just like.
And, you know, Hannah can attest to it. Her brother is in a business calc class in college right now. And they do some very, very similar stuff. He's actually going to use calculus to do it because there's a method you can maximize stuff like that too. But yeah, it's a business expert. If you guys ever played lemonade stand or crack dealer or whatever it's called, it's what's your objective? Sell more lemonade or coffee. And so you have stuff like this. This is how this stuff works. All right. What I want you to do are the next 2 for tonight. Just do those 2. No, just 2 of them. We'll work on that last one tomorrow in class because there's a weird typo that I forgot to white out.